For question 6 part A, state Kirchhoff's first law. So first law is the conservation of charge, and the second law is the conservation of energy. So for the first law, since it is the conservation of charge, so the sum of current entering a junction equals to the sum of the current leaving the same junction. Suppose this is a junction and the sum of the current, that is I, is entering a junction, so the current that is leaving the junction is also I. So the sum of the current entering a junction is equal to the sum of the current leaving a junction. And for the second law, we know that EMF is equal to the sum of the potential difference, that is EMF of the battery is equal to the sum of the potential difference V1 and V2. So EMF is equal to V1 plus V2. And for the first law, the total current entering a junction is equal to the total current leaving the same junction. Then a cell with internal resistance R is connected to two resistors R1 and R2 as shown in figure 6.1. The potential difference across R1 and R2 are V1 and V2 respectively. The terminal potential difference of the cell is V. So the terminal potential difference across this is the terminal potential difference, and terminal potential difference is always across the terminals of the cell. So this is our cell, this is the internal resistance of the cell. So this is our cell and this is the internal resistance of the cell. So this is our total cell, and the terminal potential difference is across the terminals of the cell. So across the terminals of the cell, so use Kirchhoff's law to show that the resistance R of the external circuit is given by this expression. So R is given by this expression. So first of all, so here we know that from Kirchhoff's second law, that is total EMF we consider as V. So total EMF is equal to V1 plus V2. So total EMF is equal to V1 plus V2. That is, we know that V is equal to IR. So total current, that is IR total, is equal to IR1 plus IR2. And since the current entering a junction is equal to the current leaving a junction, and for series circuit, we know that for series circuit the current remains the same. For series circuit the current remains the same. So since the current value is same, so we can eliminate I from the equation, and here we can see that RT is equal to R1 plus R2. So by using Kirchhoff's second law, EMF is equal to the sum of the potential difference. So EMF is equal to sum of potential difference, and we know that voltage is V is equal to IR. So V is equal to IR because R is equal to V by R, I. So V is equal to IR. So after substituting the values, we cancel the value of I because in series circuit the current is same. So R total is equal to R1 plus R2 as shown. For part C, the EMF of the cell in figure 6.1 is 1.5 volt. So we have given the value of EMF of the cell. That is, for the cell, the EMF is 1.5 volt. And so we know the value of EMF. The value of R1 and R2 are 10 ohm and 15 ohm respectively. The terminal potential difference of the cell is 1.35 volt. So the terminal potential difference is 1.35 volt. And what is terminal potential difference? So I have discussed that the terminal potential difference is potential difference across the terminals of the cell. Terminals of the cell, so this is the cell. So the terminal potential difference is given, that is 1.35 volt. So calculate the internal resistance of the cell. So we know that the total EMF is equal to the terminal potential difference plus the potential difference across the internal resistance. So you have to remember the equation, that is EMF is equal to terminal potential difference plus the potential difference across the internal resistance. So, and this is usual because the EMF of the cell is equal to the terminal potential difference plus the potential difference across the internal resistance. And what is terminal potential difference? So terminal potential difference is the total potential difference across the terminals of the cell. So terminal potential difference, so terminal PD plus the potential difference across the internal resistance, this internal resistance. So EMF is equal to potential difference across this internal resistance plus terminal potential difference. So EMF is equal to terminal potential difference plus internal potential difference across internal resistance. So what is the potential difference across internal resistance? Potential difference across internal resistance is equal to EMF minus terminal potential difference. So we know the value of EMF and the terminal potential difference. So if we subtract, we get the potential difference across the internal resistance. So we know the value of potential difference, that is V across the internal resistance. So we know the value of V across the internal resistance, and we need to find R. So we know that R is equal to V by I, and we need to find the value of R. We know the value of V. Now, to find the value of R, first of all, we need to find the value of current. And you have to remember that since this circuit is a series circuit, so our circuit is a series circuit, and for series circuit, the current is same, that is I. Since the current is same, that is I, so we can use any of the information to calculate the value of current. So what is the value of current? So we have given the value of R1 and R2. So by using the value of R1 and R2, we can calculate the total resistance. Because here we know that R total is equal to R1 plus R2. So R total is equal to R1, that is 10, and R2, that is 15. So the total resistance of the whole circuit is 25 ohm. So we know the value of total resistance across the terminals. So we know the value of total resistance. So the total resistance, that is R1 and R2, and so we know the value of total resistance. So the total resistance across the terminals, that is, we know the value of total resistance of R1 and R2. And since R1 and R2 are at the terminals of the cell, that is at the terminal of the cell, and we know the value of resistance. So what is the value of terminal potential difference? So the value of terminal potential difference is 1.35 volt. So we know the value of resistance, that is 25, that is across the terminals, and we know the terminal potential difference as 1.35. So current is equal to voltage by resistance, that is, we know the terminal resistance across the terminals of the cell, that is this terminal and this terminal resistance, total resistance, and we know the value of terminal potential difference. So by using this, we can calculate the value of current. So current is equal to voltage by resistance. So current is equal to voltage by resistance, and the terminal potential difference is 1.35. So 1.35 by resistance. So the resistance that we get is 0.054 ampere. So the current that we get is 0.054 ampere. So now we know the value of current, and since the current in series circuit is the same, so we know the value of current, and we have initially found the potential difference across the internal resistance. So what is the resistance of the internal resistance? So resistance is equal to voltage by current. So we know the potential difference across the internal resistance, and we have found the value of current. So we can substitute the values and find the resistance of the internal resistance as 2.777, or approximately 2.8 ohm. So the internal resistance is 2.8 ohm. That is, this internal resistance is 2.8 ohm. D. The resistor R3 is added to the circuit in 6.1. So R3 is added to the circuit in 6.1. So that the circuit as shown in 6.2. So this is the overall circuit after the third resistor is added. This is our initial circuit, and now a third resistor is added. So this third resistor is added. So state and explain the effect, if any, of this change on the current of the cell. So what is the effect of this resistor on the current? So as we can see that as the third resistor is arranged in parallel, so since the resistor is arranged in parallel, so you have to remember that as the resistors are arranged in parallel, so the total resistance decreases. Since the total resistance decreases, so the current must increase. And why the total resistance decreases? Because for parallel combination, we know that 1 by R total is equal to 1 by R1 plus 1 by R2. And let's suppose all the resistors have a resistance of 2 ohm. So 2, 2, 2. So initially, when these two resistors are connected, so the resistance total is 2 plus 2, that is 4 ohm. When these two resistors are only connected, so that is 4 ohm. But now, since an additional resistor is added, so what would be the total resistance? That is 1 by R total is equal to, so R1 is the addition of this two, that is 1 by 4 plus 1 by 2. So if we just calculate, then R total is equal to, so the R total is 1.3333 ohm. That is, as we can see that since an additional resistor is arranged in parallel, so since an additional resistor is added to the parallel, is added in parallel, so as additional resistor is added in parallel, so as the additional resistor is added in parallel, so the total resistance has decreased. Since the total resistance has decreased, so total resistance has decreased, so the current of the cell must increase. Since so for parallel combination, for parallel combination, if we add some additional resistor in parallel combination, so the total resistance, as we can see, has decreased. So total resistance have to decrease and the current must increase. Then terminal potential difference of the cell. What is the terminal potential difference? So we know that EMF is equal to terminal potential difference, terminal PD, plus potential difference across internal resistance, potential difference across internal resistance. So terminal potential difference is equal to EMF, terminal potential difference is equal to EMF minus potential difference across the internal resistance. Terminal potential difference is equal to EMF minus potential difference across the internal resistance. So as we can see that what happens to the terminal potential difference of the cell. So as we can see that initially the current has increased as the total resistance is decreased due to parallel combination, the current has increased, and since current is increased, so we know that terminal potential difference V is equal to EMF minus potential difference across internal resistance, that is IR, and since I smaller, that is I smaller across the internal resistance, and as we can see that current has increased, so potential difference across internal resistance, so as current has increased, so obviously the resistance is same. So since the resistance is same and the current has increased, so this resistance value is same, that is the resistance value same and current has increased. Since current has increased, so the potential difference across the internal resistance increases, and since the potential difference across the internal resistance increases and the EMF is same, so EMF minus potential difference, so EMF is same but the potential difference increases. Since the potential difference across internal resistance increases, and so EMF minus potential difference would give a lower value. Therefore, the terminal potential difference must decrease. So as the current increases, as we can see that the total resistance has decreased due to parallel combination, so the current increases, and since the current increases, so potential difference across the internal resistance is equal to I smaller. Since current increases, so potential difference across internal resistance increases. Since potential difference is equal to I smaller, so potential difference increases, and since potential difference across internal resistance increases, so EMF minus potential difference is the terminal potential difference, and since we have to subtract a bigger value, so the final answer is small. Therefore, the terminal potential difference is less. As current has increased, current increases. Therefore, I smaller increases. Since the resistance of the resistor is same, so the potential difference across internal resistance increases. So EMF minus potential difference is a terminal potential difference. So the terminal potential difference must decrease. So as current increases, potential difference across the internal resistance increases, and as potential difference across the internal resistance increases, so the terminal potential difference decreases.